next lesson, which is pointers, right? And pointers is really simple, really. Basically, instead of all this while, we've been using variables, right? And so, if say we need to use 10 variables, we'll have we'll allocate 10 boxes for those 10 variables, right? If we need to use the variables in different locations, let's say for example we have 3 functions and each make use of 10 variables, that would mean that we need 30 boxes for 10 variables times 3 functions, right? So this is one way of manipulating a variable, and it's, to be fair, it's quite wasteful because then we need 9, 10, 30 boxes when in actuality we only have 10 variables to play around with. Means say that you don't need to, basically we need to duplicate it again and again and again, right? So it would be nice if we can have a way of just pointing to a variable. Let's say we have 10 variables, so we allocate 10 boxes, and then in the other functions that we also need the same number input from the user, we can just say I give you a pointer, some kind of an arrow or something, and this pointer is always pointing to the first box or second box and so on, right? So we have this kind of a situation. Right? So all this while before we start using pointer, right? Let's say we have function 1 and then 2 and then 3, right? Like I said earlier. So in function 1 we have 10 variables, function 2 we have 10 variables, function 3 we have 10 variables. But we've noticed already inside the functions, right? When we actually get the variables from one point to another, we're actually just copying the variables, right? So we actually don't need those many boxes now. It's like, we have 10 boxes for function 1, 10 boxes for function 2, 10 boxes for function 3. This is already 30 boxes, when in reality, we are only expecting around 10 or maybe less variables from the user, right? So why do we need all these boxes, right? So another way of using this, another way of looking at this is, what if we can have, for example, 10 boxes, right? Maybe I should have gone with a smaller number, yeah? Don't have to go 10 boxes. Let's say we have 10 here, right? Let's say we have, these are the user inputs. And then the rest of the boxes are maybe average, total. So these are just boxes that we can use ourselves. We don't really have to copy it from one point to another. So instead of 10 boxes, I can have instead functions 2 and 3 will have a pointer, right? So for example, this is box A. I can have pointer AA and pointer AAA and pointer AAAA, for example, right? And all of these will point to the same box. So pointers make use of much less memory space, but works pretty much as well. Maybe it can even be a lot more flexible because we don't have to carry boxes around. I mean, imagine that, lah. Imagine it's like having a shortcut, right? So in our computer system, we might have folders, we might have files here and there, right? And if say we take a file and we make a copy of it and put our desktop and so on, it might slow down our computer, that kind of thing, right? So instead of putting that folder or file, make copies of that and then making use of all of the storage space and etc., we can use a shortcut. All of you have used a shortcut before, right? Just create an icon. You've used a shortcut before, right? So instead of recreating the file, making a copy, because sometimes making copy gives a little bit of trouble as well. Let's say for example you have an assignment, you're working on an assignment, right? And let's say you take, for example, 5 subjects. So your assignment are in different locations, but it's urgent. Next week is a deadline, for example, right? So if you are to go from folder to folder, it's such a hassle. So if you, hey, you know what, is it nice if I have all of these assessments on the desktop, right? But on the desktop, you also have other kinds of work and so on and so forth. That's one thing. And then another is, if I put it on the desktop, sometimes our history file might have the same name, file name twice or something, and we're not sure which one is the updated one. So this is a bit of a hassle. There's in terms of file integrity, we're not sure which one we should be updating. That's one thing. Another is we're being inefficient because we are keeping the same file in many locations. So instead of having that kind of situation, what you can do is you can just have a shortcut and put the shortcut where it is most convenient, meaning to say that whenever you want something, you go to a certain location and get everything from that particular location, right? So you can put the shortcut on desktop, so your file integrity remains and you don't make use of that many storage space. So pointer is something like that. So we just have an arrow and just point at something. It's as simple as that. So to learn how to declare, initialize, and use pointers, familiar with dynamic memory allocation and deallocation, use pointers with common programming situations, involve optional and shared objects, understand relationship between arrays and pointers. So in arrays it's even more interesting because it can point to the whole thing, right? So memory address, recall that a reference parameter sends the address or the reference of the variable with x and an ampersand, right? So this is how we, for example, if we want to send reference, right? We can use integer ampersand x like that. So we've done this before, right? This is manipulation by reference, right? So we can manipulate by value. When we manipulate by value, what happens is that we actually have two boxes. So the content of one box will not affect the other, right? We'll just copy the value into another box, right? A and then A1, right? Let's say this is function 1, F1, this is function 2, and we just copy the value. So whatever happens here doesn't affect here, right? So this is passed by value. Then we also did pass by reference, integer ampersand x. We did that in those function. The value parameter y creates a local copy of the variable. When the program is running, all variables are kept in the memory heap, right? So everything will be in the memory heap. So the memory has, we call it random access memory because the computer are able to go here and there really quickly to fetch whatever needed to be fetched, right? Each variable is stored with a hexadecimal address, for example, like that. 0012FED4. So we know where to find it in the heap, or rather the processor knows. Either it can be the processor, it can be the operating system, it can be the compiler, depending on what type of job, right? For example, here integer x equal to 42. What happens is that 42 will be kept in the box called x, and the box called x is only expecting integers, right? Prints out value of x when we do the cout x, right? Whereas cout ampersand x will actually print out the address, which is what we have there, 0012FED4. So there's a difference between the value and the address of a variable, right? Value and address are two different things. So when you use a pointer, you're actually pointing to the address, right? We can sort these addresses using a special data type called the pointer. Because the pointer points to the address, it's like, it's a shortcut. A pointer is denoted by an asterisk, so points to, right, and the ampersand is address of, right? So here integer x is equal to 23, right? So 23 is committed to the box named x, right? So you have an integer. If we have an integer asterisk p, so we create a pointer to an integer, right? And p will point to ampersand x, right? So now p stores the address of x. Whereas technically speaking, we are almost saying here that asterisk p is equal to x, right? Meaning if we see out asterisk p, we actually get 23. Whereas if we print out, if we see out p, we get the address of x, regardless of what the address of x is. Pointers can point to anything at all. Right? Pointers don't have to point to integers. We can point to any variable that we want. Right? Integer x is 23. Pointer asterisk pointer x double w which is 4.4. Right? So we can also use the integer q to point at a w and so on and so forth. Actually, technically, you can also do it for float. We can actually do it for regular variables as well. It's just that here it makes a bit more sense when we do it with a pointer.